So if a function f is differentiable at a point C, then it is also continuous at that point. F dash of C is equal to limit x tends to C of f of x minus f of C divided by x minus C. So dy by dx is equal to f dash of x. If this limit exists, then the derivative of the function is denoted as f dash of x is equal to dy by dx. D by dx of x to the power of n is always equal to nx to the power of n minus 1. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, faculty, Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. In this session, I am going to discuss regarding very important chapter, that is differential calculus. So here you are going to study the differentiations of different methods. Now, before going to the exact differentiations, let us know regarding the weightage for this chapter. Now, what is the weightage for this chapter means? So, in the examination, you will get 11 marks from this chapter. So, all 1 mark question, 2 marks question, 3 marks question and 1 5 marks question, all 1 question. So, 1 mark question you will get, and again 1 2 mark question, 1 3 mark and 1 5 marks question. Totally 5 plus 3, 8 plus 2, 10 plus 1 is 11 marks from this chapter. So, 1 mark 1 question, 2 mark 1 question, 3 marks 1 question and 1 5 marks question. So, totally this carries 11 marks and very important chapter. From previous classes, you might have been studied the derivative of a function. Let me discuss the standard result, the basic differentiable formulas, standard results in differentiations, the standard formulas in differentiation. Now, you might have been studied derivative of a constant. Derivative of a constant is 0. D by dx of k is equal to 0, where k is a constant. And derivative of x, d by dx of x is equal to 1. And d by dx of x square, differentiation of x square is equal to 2x, and similarly d by dx of x cube is equal to 3x square, and d by dx of x raised to n is nx to the power of n minus 1, where n is any rational number. Based on this, we are going to derive. So d by dx of x is 1, d by dx of x square, using d by dx of x to the power of n, we have n is equal to 2 into x to the power of 2 minus 1, that's equal to 2x power 1 is equal to 2x. So, derivative of x square is 2x, and similarly d by dx of x square, n is equal to 3, x to the power of 3 minus 1, that is 3x to the power of 2. So, these things you might have been studied in your previous classes. Now, therefore, d by dx of x to the power of n is nx to the power of n minus 1. Similarly, d by dx of root x is 1 over 2 root x, and d by dx of 1 by x is minus 1 by x square, because you know d by dx of 1 over x can also be written as d by dx of x to the power of minus 1. So, what is n here? N is minus 1, x to the power of minus 1 is minus 1 x raised to minus 2. Just bring this to the denominator, minus 1 by x square. D by dx of 1 by x is minus 1 by x square, and derivative of e to the power of x is e to the power of x. Okay. These are few things you might have been studied in your previous classes. So, I will derive 1 or 2 using first principle. So, we are going to study derivative of all these type of functions using first principles or by definition, that I will explain it, how we are going to get it. Now, similarly, d by dx of trigonometric functions and logarithmic functions, differentiation of log x is 1 over x, and differentiations of 6 trigonometrical functions, d by dx of sin x is cos x, d by dx of cos x is minus sin x, and similarly d by dx of tan x is secant square x, and d by dx of cosecant x is minus cosecant x cot x, d by dx of cot x is minus cosecant square x, and d by dx of secant x is secant x into tan x. So, these are all the formulas which you might have been studied. In this unit, you are going to derive all these formulas using the definition or by first principle method. So, there we are going to study how we are going to get d by dx of sin x cos x and d by dx of cos x as a minus sin x. Now you might have been studied the derivative of a function exists if the limit exists. So, dy by dx can also be written as limit x tends to 0 of f of x. If this limit exists, limit x tends to 0 of f of x plus delta x minus f of x divided by x plus delta x minus x. So if this limit exists, then this is nothing but limit x tends to 0 of f of x can also be written as f dash of x. That is called the derivative of the function. You might have been studied in your previous classes. Now, let us come to the very important concept, relation between continuity and differentiability. Now, relation between continuity and differentiability, you might have been studied the continuity in your previous classes. Now, what is the relation between continuous function and the differentiability? So, if a function f is differentiable at a point C, then it is also continuous at that point. Suppose if a function f is differentiable at a point C, then the function is also continuous at that point. Now let us come to the proof. Let us consider, since f is differentiable at C, we have this value f dash of C. F dash of C is equal to limit x tends to C of f of x minus f of C divided by x minus C. If this limit exists, limit x tends to C of f of x minus f of C by x minus C, then it is called a f dash of C. Suppose if x is not equal to C, suppose if x is not equal to C, then this f of x minus f of C can be written as, just multiply and divide by x minus C for this. This is equal to f of x minus f of C divided by x minus C into x minus C. This x minus C and x minus C gets cancelled. We will get f of x minus f of C when x is not equal to C. Now, just apply the limit for this. If you apply the limit for this, taking limit on both sides as x tends to C, now therefore, limit x tends to C of this f of x minus f of C can also be written as limit x tends to C of this right hand side, that is f of x minus f of C divided by x minus C into x minus C. Just taking limit on both sides as x tends to C. Now, just using the properties of limits, so you can also write this as limit x tends to C of term by term application. So, limit x tends to a of f of x plus or minus g of x can be written as limit x tends to a of f of x plus or minus limit x tends to a of g of x, term by term evaluation. So, limit x tends to C of f of x minus similarly limit x tends to C of f of C is equal to, just apply the limit for this, limit x tends to C of f of x minus f of C divided by x minus C into limit x tends to C of this x minus C. Now, apply the limit. So, taking limit on both sides and applying the limit. So, limit x tends to C of f of x minus limit x tends to C of f of C is equal to limit x tends to C of f of x minus f of C by x minus C is equal into limit x tends to C of x minus C. Now, since we know that this value, since we know that f dash of C is also equal to, f dash of C is equal to limit x tends to C of f of x minus f of C divided by x minus C. So, this is equal to f dash of C into, if you apply the limit x is equal to C, C minus C is 0. So, this is equal to 0. So, f of x minus limit x tends to C of f of C is equal to 0, that is limit x tends to C of f of x is also equal to limit x tends to C of f of C. Limit x tends to 0 of f of x is equal to limit x tends to C of f of C. So, this is nothing but f of C. So, that means limit, therefore, limit x tends to C of f of x is also equal to f of C. Therefore, the function f of x is continuous function. So, that means what is the conclusion? So, a function f is differentiable at any point C is also a continuous function. So, a function f of x which is differentiable at any point C is also continuous at that point. The final conclusion is a differentiable function at C is also a continuous function. That's it. Okay. Now, let us come to the very important concept, derivative of a functions using first principle. So, differentiation of some important standard functions from first principles. So, a function can be differentiated by the method of first principles or by the method of definition. Now let us consider function. Before going to an example, let us consider a function. Let y is equal to f of x is a function. Let us represent this as equation number 1. So y plus delta y can also be written as f of x plus delta x, changing x to x plus delta x. Y changes to y plus delta y. Delta x and delta y are the increments. Now just 2 minus 1 equation 2 minus 1 gives y plus delta y minus y is equal to f of x plus delta x minus f of x. So minus y plus y gets cancelled. Delta y is equal to f of x plus delta x minus f of x. Now divide both sides. Divide by delta yx on both sides. Divide by delta x. Delta y by delta x is equal to f of x plus delta x minus f of x divided by delta x. Now taking limit on both sides, limit delta x tends to 0 of delta y by delta x is equal to limit delta x tends to 0 of f of x plus delta x minus f of x divided by delta x. So if this limit exists, so that is if this limit exists, limit delta x tends to 0 of f of x plus delta x minus f of x divided by, for this delta x just add and subtract x, x plus delta x minus x. If this limit exists, then that is equal to what we will have in the left hand side, limit delta x tends to 0 of delta y by delta x, then we are going to get dy by dx. So dy by dx is equal to f dash of x. If this limit exists, then the derivative of the function is denoted as f dash of x is equal to dy by dx. Differentiating a given function using this method is called the derivative of a function by first principles or by definition. So now let us come to the first problem. What is the problem given? Differentiate x to the power of n using first principles. Now this can be differentiated using first principles or by the method of a definition. Now let us consider, let y is equal to x to the power of n, equation number 1. So changing x to x plus delta x, y changes to y plus delta y. So this can also be written as y plus delta y is equal to x plus delta x to the power of n. Now equation 2 minus 1 gives, what will gives y plus delta y minus y is equal to x plus delta x to the power of n minus x to the power of n, minus y plus y gets cancelled. Delta y is equal to x plus delta x to the power of n minus x to the power of n. Now divide throughout by delta x, then what you will get, delta y by delta x is equal to x plus delta x to the power of n minus x to the power of n divided by delta x. Now taking limit on both sides, taking limit as delta x tends to 0 on both sides. So if we take limit on both sides as delta x tends to 0, this is limit delta x tends to 0 of delta y by delta x is equal to limit delta x tends to 0 of x plus delta x to the power of n minus x to the power of n divided by, for this delta x just add and subtract x in the denominator. So x plus delta x minus x. Now this is dy by dx is equal to, that is nothing but f dash of x is equal to, f dash of x is equal to, this can be evaluated by taking the substitution. Now let us put z is equal to x plus delta x. So when a delta x tends to 0 implies z tends to x plus delta x, x plus 0 as x. So this limit delta x tends to 0 converts to z tends to x of z to the power of n minus x to the power of n divided by z minus x. Now this is nothing but f dash of x is equal to, now observe carefully, this is of the form limit x tends to a of x raised to n minus a raised to n divided by x minus a. So limit z tends to c of z raised to n minus x raised to n z divided by z minus c, x raised to n minus a raised to n by x minus. So this can be written as n into x to the power of n minus 1. So therefore f dash of x is equal to nx to the power of n minus 1. What is this? Therefore, d by dx of f of x is nothing but x raised to n. D by dx of x raised to n is nx to the power of n minus 1 is the derivative of the function. So, this type of differentiation is called a derivative of a function by first principles or by the method of a definition. Very important concept. So, just take given equation as y plus delta y can also be written as y plus delta x to the power of n. 2 minus 1 gives delta y, divide throughout by delta x, taking limit on both sides as delta x tends to 0. If you want, you can also convert x to x plus h and taking limit on both sides as h tends to 0. That is also one of the easiest method to solve this problem. Okay. Now, this is how we are going to differentiate a function using first principles. Hope you followed. Okay. Similarly, we can differentiate all trigonometrical function d by dx of sin x, cos x, tan x, cot x, secant x, cosecant x, e power x log x using the method of first principles that I will take after taking. Let me discuss some examples based on this formula, and then I will take the differentiations of all trigonometrical functions using first principles. Now, let us come to the final conclusion. So, therefore, d by dx of x to the power of n is always equal to nx to the power of n minus 1. Now, where n is a rational number, suppose if n is a positive integer, d by dx of x cube can be written as 3x to the power of 3 minus 1 is 3x square. Similarly, if d by dx of x to the power of 4 is equal to 4x to the power of 4 minus 1 is 4x cube. Suppose if it is d by dx of x to the power of 100, then this can be differentiated at 100 x to the power of 100 minus 1 is 99. The one power goes on decreases. Now, suppose if n is a negative integer, d by dx of x to the power of minus 1. Here n is equal to minus 1, x to the power of minus 1 is minus 1 x to the power of minus 2. Just bring this to the denominator, minus 1 by x square. So, d by dx of x to the power of minus 3. What is n here? Minus 3 x to the power of minus 3 minus 1 is minus 3 x to the power of minus 4 or minus 3 by x to the power of 4. Suppose if it is d by dx of x to the power of 1 by 2, a fraction, positive fraction. What is n here? N is equal to 1 by 2 x to the power of 1 by 2 minus 1, 1 by 2 x to the power of, take LCM, 1 minus 2. This is 1 over 2 x to the power of minus 1 by 2. Or suppose if it is d by dx of root x. What is root x? Root x can be written as d by dx of x to the power of. What is d by dx of x to the power of? You will get 1 over, just bring this to the denominator, minus of becomes plus of, this can be written as root x. So, differentiation of root x is 1 over 2 root x. These are all few basic formulas based on this d by dx of x to the power of n. So, if n is a positive integer, n is a negative integer and n is a fraction, positive fraction. Suppose if n is a negative fraction, we can write d by dx of x to the power of minus 1 by 3 can also be written as minus 1 over 3 x to the power of minus 1 by 3 minus 1. This is minus 1 over 3 x to the power of minus 1 minus 3 by 3 is the LCM. Minus 1 over 3 x to the power of minus 3 minus 1 is minus 4 by 3. Bring this to the denominator. Minus 1 over 3 into x to the power of plus 4 by 3 is the differentiated answer for this. So, n is minus 1 by 3 x to the power of minus 1 by 3 minus 1. 3 is the LCM. Minus 3 minus 1 is minus 4 by. Suppose if it is like this, d by dx of cube root of x to the power of 5. Now, this can be differentiated. D by dx of cube root is nothing but x to the power of 5 whole raised to 1 by 3. This is d by dx of x to the power of 5 by 3. What is n? N is equal to 5 by 3 x to the power of 5 by 3 minus 1, that is 5 by 3 x to the power of, just take LCM, 3 is the LCM, 5 minus 3. So, 5 by 3 into x to the power of 2 by 3 is the differentiated answer. Few examples for this. Now, you might have been studied one more formula in your previous class, that is called the product rule. Now, what is the product rule and quotient rule? The product rule is d by dx of u into v, that is u into dv by dx plus v into du by dx, that is first function into second function. First function into differentiation of second function plus second function into differentiation of first function. On the other hand, you might have been studied the quotient rule. D by dx of u by b is also equal to b into du by dx minus u into dv by dx divided by b square. This is called the quotient rule. D by dx of numerator by denominator is denominator into differentiation of numerator minus numerator into d by dx of denominator divided by denominator square. Let me take one small example. If it is like this, d by dx of x square into e to the power of x. So let us consider this first function and second function. X square constant, d by dx of e to the power of x plus e power x constant, d by dx of x square. So wherever d by dx, differentiate it. So x square into differentiation of e to the power of x is e to the power of x plus e to the power of x into differentiation of x square is 2x. So you can take e power x common factor out. X square plus 2x is the differentiation of the given function. Okay. Suppose if you want to differentiate x square by e to the power of x, suppose using quotient rule, you can also differentiate x square by e power x. So denominator into differentiation of x square is 2x minus numerator x square into differentiation of e power x is e power x divided by e power x whole the square. So if you want, you can take e power x common factor, e power x common factor out, 2x minus x square divided by the denominator we have, one term gets cancelled, this is equal to 2x minus x square divided by e power x. So this is how we are going to differentiate a function using product rule as well as using the quotient rule. Okay, these are very important concepts which you might have been studied in your previous class. Similarly, we can differentiate all the functions. D by dx of sin x, derivative of sin x is cos x, and d by dx of cos x is equal to minus sin x, and d by dx of tan x is equal to differentiation of tan x is secant square x, and similarly d by dx of cot x is equal to minus cosecant square x, and d by dx of secant x is equal to secant x into tan x, and d by dx of cosecant x, d by dx of cosecant x is equal to minus cosecant x into cot x, and as I just write d by dx of just now I wrote d by dx of e to the power of x is e to the power of x, and d by dx of log x to base c is equal to 1 over x. So these are all the important formulas which we might have been studied in our previous class, and we can find the derivatives for all these using the first principles or by definition. First principles. So by first principles or by definition we are going to solve. So these are all some basic information regarding the differentiability. So that's all regarding today's session. Let us meet with a different concept in the next class. In the next class, I am going to take the differentiations of all trigonometric functions using first principles. So don't miss the class, attend the class. Thank you very much.